All right, we are set up for our next panel. And for this panel, I'd like to bring on 4 amazing founders. Sandeep from Polygon, Rene from Celo, Alex from zkSync, Matter Labs, and Steven from Offchain Labs. We're going to be talking about what's actually happening in the world of building on top of different L2s and a bigger ecosystem around how do we offer application-specific experiences. So to have this conversation, please join me in welcoming Sandeep, Rene, Alex, and Steven. So I'll be honest, I think we have to figure out live what the discussion is going to be about, because a lot of things we can talk about, and hopefully we get into some fights, because that's what makes it entertaining. But I think kind of the title we came up with this was aggregated or stacked. But as I was prepping for it, I realized there's probably a better way to think about what's actually happening. And kind of the theme here that we want to cover is that effectively a lot of blockchains, especially L2s, want to think about the best experiences for the developers and the builders on top of those applications. And as they think about reaching scale, they have different requirements, they have different needs, they have different resource allocation requirements that they need to worry about. And that opens up a whole new surface area for what you can offer. We've kind of seen OP Stack, we've seen a bunch of, Jesse just talked about L3s on kind of their way to think about it. We've seen different ways of experiencing different stacks to do from CDKs to zk stack. But the overall theme always ends up being, well, how do we actually connect all these things together? And like, what does that long-term scenario looks like? If you're going to have thousands of these things, does that mean it's just extreme fragmentation? Or does that mean we got to 1,000 because we actually made it super easy to not worry about fragmentation? But kind of the correction on aggregated versus stacked for me is actually the differentiation between monolithic versus modular versus aggregated, which I think is kind of the conclusion I came up with. So with that as a preface, what I want to do is I want to kind of just start with Sandeep and have you talk about what is the aggregated vision that you just announced recently, and we'll kind of use that to frame everything else in context.
Yeah. So to understand aggregated, like just a brief history that, blockchain started as these monolithic, single chains where, like all the smart contracts are living in one single virtual machine, and there's a one single state machine. And, those smart contracts have a lot of composability with each other. But the problem is that, if that is a single state machine, there are inherent, problems with the scale, because there is like all the transactions are hitting one single state machine. Then the monolithic thesis came along, which is like you can have different like hundreds of rollups, as we said, thousands of these rollups. They can use their own data availability, own kind of proving systems and all that, and derive from the security of Ethereum, preferably. So in that setup, you have like huge amount of scale, but problem is the fragmentation, right? Like, because those chains are inherently separate with themselves. But the aggregated thesis is that basically instead of like these individual state machines, you have aggregated state machine. And that we intend to achieve using the power of zk, where you can have all these state machines and the virtual machines running on top of them. They publish their zk proofs, and we aggregate them together in one single proof, so that using that aggregated proof, these chains can have cross-chain interoperability, and they don't have to rely on the crypto economic security of each of these chains, which kind of like later on can create scaling problems. And the goal there is that we want to create like the internet Web 2, current internet kind of environment, where I even see these individual like single sequencer chains as like trustless servers. Like, there's not even like, we just complicate them, calling them chains and all that. These are trustless servers. Just like in Web 2, you have trustful servers, which can interact with each other with, standard RPC methods and all that. And there is seamless interface for the user. Here, these will be like trustless servers. And using that, using zk, you can achieve that trustlessness. But other mechanisms like optimistic mechanisms and all that can also achieve that kind of effect.
I mean, that was a great intro, and I think then it sort of puts the spotlight on Celo. You start as an L1, and that was kind of the monolithic approach. Hey, we see all these issues. We think we can correct it because we get full control over the stack. And then 7 or 8 months ago, you kind of decided to consider the OP stack. So maybe walk us through how you kind of came to the decision, or why you came to the decision, and I guess what's happening now. Is that still the case? Where are you in that process?
Yeah, for us, let's just say the world got a lot more complex since C-Labs first core engineering team put forward the proposal, and I will say at the same time the excitement to be an L2 to Ethereum long term has risen even more. I think it's clear that a lot of the mindshare and a lot of the density, right, of innovation is going to be in the Ethereum ecosystem. So that continues to be, super exciting. Now, with respect to the architecture, it is interesting, right? Because in many ways, as an L1, you very much, you think about sort of what are all the things that Jesse just made this kind of comparison of like countries and states, right? And you kind of have to like see, okay, how do we get all the pieces that are necessary for the citizens, right, to access the infrastructure, right, that's needed to actually, now like blockchain terms, to build the applications that you want to see in the world. And I think that mindset can shift with the L2, right? So a lot of the vision there is that in the long term, you probably have one big economic zone, right, that connects all the L2s, maybe L3s, right? And that is great, but in the short term, we're not there yet, right? So in the short term, it's actually, you have a bunch of different economic zones, and I think a chain like Celo that's making this transition has to figure out, okay, what are things that we have and what are things that we can gain from being part of a certain economic zones, and or what are the benefits, if we now kind of go back to like the stacked view of that, right? What would be benefits for someone to, for example, launch an L3 on Celo? And that's pretty interesting because I don't actually think it's kind of an or, right? It's not like you either kind of believing in one or the other thesis, but I see sort of both coexist, right? There will be, projects launching chains that will want to, for example, in the case of Celo, right, gas currency, some of the features will adopt those at the L3 level, or even be happy with the finality, given the decentralized sequencer that our, validators are going to become sequencers can provide versus sort of Ethereum finality. And obviously there are cost trade-offs there. But ultimately, I think there's sort of the thing that I think I would be curious to hear the others. This is a little bit hard to kind of evaluate right now. What's the benefit actually of the ability for a user, right, to use applications across a bunch of different ecosystems, right? Right now, this is like the data we have is maybe a little bit, skewed, right? Because, a lot of the early adopters in this world are hunting airdrop.
Implementations, trying to...
Right? But what is sort of the real necessity for someone to actually use application across 5, 6, 7 different L2s or chains? And that's I think less clear, but I think it's an important consideration. So I answered the first part of that question, but I also talked a lot, so I'll stop here.
I think that's actually so helpful because it does set the context for the rest of this chat. So maybe I'll just kind of jump directly to Steven, which is kind of given what Celo talked about as they kind of originally considered the OP stack and the aggregated view now. How do you kind of, how does the antitrust vision fit in here, and what is it for audience as well?
Yeah, so in the Arbitrum, it's more like the Orbit vision. Antitrust is part of it. The Arbitrum vision, or the vision that I have, I should say, for the Arbitrum ecosystem is one of, there will be a few public chains that are very, very, general purpose and have high adoption. We see that today in Arbitrum 1 leading in DeFi. We see Arbitrum Nova doing a ton in gaming. And then there will be a proliferation of projects that need to have their own chains. And the question is, what do those chains look like, and how do they connect to each other? And how can they sort of, get these interop or efficiencies, and how do they get that functionality? So in this vision, there's this idea basically called a chain cluster, which is this notion that different chains can sort of cluster themselves to get fast interop between them. And in doing so, they'll have to sort of attach themselves in a particular way. And we're very much of the, and this is kind of like the superchain concept, which you may have heard about in the previous talk. And I'm very firmly of the belief that it doesn't make sense for there to be one superchain for everyone. And the reason is you have to give up a lot, because the idea is if there are two chains, chain A and chain B, and chain A can send funds quickly to chain B, quickly meaning faster than Ethereum settlement, then what happens is negative things can proliferate. If there's a hack on chain A, it can quickly send a bag to chain B. So you sort of have to trust very much everyone in this zone. And that's why that's why, as Jesse just mentioned, Optimism has governance as a service, and they basically, in their case, have to govern this chain and make sure that everyone's running the software that's approved and the software that follows, that they vetted, and they're not concerned about their security. But we very much in the orbit land, security is obviously critical. But we want to give people the ability to do customizability. So you'll have Arbitrum orbit chains that do like very differentiated things. Some may do things that just change the economics and allow creators to have direct royalties on chain or enforce that on chain. But some may do things that are like very deep. There's a team called Phoenix that they're actually building a chain with deep cryptography embedded, FHENIX. So FHE is for fully homomorphic encryption. Now, if you're running one large chain, it would be very hard for us to get to confidence that they have confidence and they should have confidence, but do I really have the ability to vet Phoenix's code? Me as a different chain developer, do I want to take them on as part of my cluster? No, what happens is if you have one, you sort of limit customizability. And another great example, by the way, a simpler example is data availability. So we're seeing a proliferation of different data availability services. Now they all have slightly different models and slightly different potential failure cases, right? So you have AnyTrust, which is the data availability, it uses a data availability committee that's, Arbitrum Nova is running, but you also have Arbitrum integrations with Celestia, with EigenDA, with Espresso, et cetera, with NEAR, and, you can go down the list. And each of these has a slightly different trust model. And if Arbitrum 1 was to cluster itself with an alternative DA chain, it would sort of get the worst of all security. So we think that these clusters should be organic shards that decide to connect themselves. It could be the gaming chains, the wacky cryptography chains, if you will, the Celestia chains. I don't know exactly how it will happen, but I believe that there should be these clusters of really good interop, and then you have to build really good bridging in between these different clusters as well. And that's one thing we're working together with the Espresso team on shared sequencing, which is another really big piece of this puzzle. But I think together with these various technologies that sort of complement each other, you can build a really good story of how to both have customizability, and you can take the Arbitrum code, Arbitrum Orbit, you can launch as an L2 or an L3, but not only launch as an island, also get really good interop via other chains in your cluster, or more broadly to the Arbitrum ecosystem, or via things like Espresso more broadly to the rollup ecosystem. Because I think one of the themes here, at least for me, is interop shouldn't be limited to a single ecosystem. If you have the Polygon chains, I know your aggregation layer is a similar vision. If you have the Polygon chains, only talk to the Polygon chains, the Arbitrum chains, talk to the Arbitrum chains, etc. You haven't accomplished.
It's unnecessary Celo. You don't want that.
100%. So our goal is to sort of say, how can we break past that boundary as well?
It will be like, if you see the Web2 analogy, it will look like, okay, if you have a Linux website, you cannot, interact with the website which is running on a Windows server. It should not be like that, right? So these chains should, in the long enough scenario, these chains, when a user is interacting with these chains, for them, all of them should feel like one single chain. Just like when we connect to the internet, we don't have to connect to the...
You don't need to worry about what database is storing your data on any...
Yeah, and that's ultimately, I think, because the thing that unites all of us here, and Celo too now, is we're very Ethereum aligned, Ethereum based, and we all have our own sort of project to promote, or we're very, very partial to, but we also all, I think, care very deeply about Ethereum, and we don't want to create a fragmented or fractured Ethereum. It may happen a little bit in, your best interoperability may be between two chains of the same stack, but I think there's a lot that we can do, and it should be a focus, of mine to say, hey, how can we interoperate with zkSync and with Polygon and with Celo on whatever stack that they end up with.
And I guess so finally, Alex, maybe kind of having now heard all of that, let's kind of comment on the zk stack and hyperscalability, and sort of where do you think that fits in?
Yeah, so we at zkSync, we're building something called the hyperchain network, which is a very similar idea. I think we are all talking about the same vision of Web3 as the internet of chains. Because I think we all came to conclusion that it's like the internet cannot be built on one single server or on one data center or like on one platform. So is the situation with Web3. like if we're building the internet of value, it must resemble internet in its ability to scale infinitely without any limits and bounds, and to have many heterogeneous systems that are governed by different people, by different communities, different organizations. And this is the question is like how you solve it with technological approaches, like what they're going to use to create this this network. At zkSync, we believe that there is only one technology that can solve this. There is like it's decided it's going to be zk. You will have all of these chains like.
Now we're getting somewhere.
Eventually, yeah. I mean, like, you ask for it.
Even throw this.
I mean, eventually, all these chains will have to upgrade to zk for a very simple reason. We want to build system like this network must be trustlessly interoperable. So, like all of those chains must be able to talk to each other, irrespective of trust assumptions. Right? You can't scale economic trust assumptions. Even if you subjectively believe that this chain is safe, you cannot convince a third-party system about this. But you can easily convince a third-party chain that this chain has executed certain transactions because there is a zero-knowledge proof that guarantees that. And the beauty of zero-knowledge proofs is what we now call the zk singularity is you can aggregate proofs of different chains, maybe unlimited number of transactions within each chain, and then these chains together, and until you get one single proof which you settle on layer 1 on Ethereum. Then you generate the proof for Ethereum block itself. We are at a stage where we can do it. And then every single wallet, every single mobile phone in the world will have built-in verifier, which you can check in 1 second, and you have the latest Ethereum block, and you know that it's correct from Genesis. All the transactions of Ethereum, all the transactions on the thousands of permissionless chains that are being aggregated and being settled there are valid. And you don't care who runs them. And the beauty of it, and really the focus of what we're doing at zkSync, where we're going to be fighting, I already see the big fight coming, and we'll talk about this hopefully in a second, is we must ensure that the Web3 remains sovereign from the perspective of individual user and individual chains. We don't want to push everyone under the same exact standard, under the same, a few big centralized providers that are going to be serving everyone in a trustless, don't be evil way, as we've seen this happening in the big tech before in Web 2. We need to protect that. And this is the priority of the design choices of zkSync, to make sure that all those chains are completely separate. They can have completely separate consensus algorithms, sequencers, centralized sequencers, decentralized sequencers, be owned by different people, have different tokens, whatever, but they should all interoperate as though from the user experience should be like email. You have your email address at Alex at Matter Labs, you have Kartik at ETHGlobal. I should not care. I send a message, I know that the message is point-to-point encrypted and authenticity is guaranteed. There are no people in between who can tamper with this message. If I'm sending from Matter Labs to Gmail account, I should not have need to have two Gmail accounts to interact with each other. I should be able to send it from any third.
So I'm on a hunch here. I'll let Steven comment.
First, which martial arts we are choosing for the fight? Is it Kung Fu, Karate, or maybe Nerd Fight?
Angry comments.
Let's choose Nerd Fight.
Shotokan. Okay. Yeah, so here's and actually I had a very similar conversation, Masari made it this year with Brendan Farmer. We actually came to the same conclusion, which is the following. There is, I think, a lot of hype out there and a lot of bit of hand-waviness, so I'm going to be specific, and I'm sure there'll be responses here, so I encourage it. I might get beaten up from both sides here, so I have a disadvantage. But the thing is, the problem is time, and the timeline is the critical problem here, and the timeline to address. So let me tell you what I mean. At Offchain Labs, besides for building Arbitrum, we built Prism. Prism is the leading consensus client for Ethereum, and one thing that I know is Ethereum consensus takes time. And when the Ethereum consensus takes about 12 to 17 minutes on expectation for finalization. Well, finalization, it doesn't mean Ethereum blocks take that long.
Okay, so finalization at the
You can't get reorged. So you know that, like, okay, this transaction
to 100
has finality and it won't get reorged. And so here's the big problem, and here's why that number is fundamental and critical to this conversation. Okay, so you have two zk chains. We'll call it chain A and chain B. How does that sound? You're A, you're B. You have two zk chains, and let's pretend that they're both producing proofs immediately too. It doesn't really matter, because it really matters settlement on chain. That's not the case today, but let's just assume that they're both producing proofs immediately. I know the Polygon team recently had an announcement which they made some really good progress towards that, which is exciting. So let's just pretend that that's in the case today. So you have chain A and chain B, and they have proofs immediately. And let's say these proofs are posted immediately with data on chain. Now, the vision that was just described is, hey, we don't want, for a sequencer, you just have basically proving. So I verify this proof, and this verifies that. There's no like intermediate trust. There's no intermediate optimistic assumption, because we're just verifying these proofs as they happen. But that's where that 12 to 17 minute thing happened, because you can give me a chain and you can give me an immediate proof. But this thing that tells me that chain is the canonical chain and the transactions are actually the transactions of that chain is the finality of Ethereum. Because here's what happens. You post your transactions on chain, again, immediately. It doesn't really happen immediately, but I'm going to grant you that immediately. You post a proof on chain immediately. And then 11 minutes later or 12 minutes later, there's a reorg on Ethereum, and it turns out that that proof is correct for that set of transactions, but that set of transactions is no longer the final set of transactions, right? Because Ethereum is the source of truth here. We need Ethereum finality to tell me what are the inputs before we talk about what are the outputs. So I'm granting you the benefit of the doubt and saying all the outputs are immediate, but you need all of those inputs to be finalized to actually know what the chain is. So the proof can be there, but it's proving a chain that I don't actually know is the correct state of the chain today. So it's not the case that you can have two zk chains that automatically, they can try to condition on different transactions and say, I'll do it conditioned on that this has transactions, but ultimately all that can change, and it can lead to a big reorg if one of them changes, and that's not the set of transactions. So I think if you want to build a system that every time there's a block or user transaction, it waits 12 to 17 minutes to get that interop, that's wonderful, and I think that zk technology can do that for you. But actually, what the interop that users want is something a little bit faster than that. They want fast and immediate interop. And if you're relying on Ethereum security, which is what we're Ethereum security, the zk proofs alone don't need to do that, because I can give you a zk proof of a chain A and then just swap out the transactions of the chain B. And actually, so when I spoke to Brendan about this at Masari Mainnet earlier this year, I think it was in September, he said, and you can look back at the video, he said, Steven, you're going to love this. I want to tell you. He said, there's an optimistic assumption built in here. And of course, there's an optimistic assumption.
Exactly what I was going to say. It was like we just introduced a buffer, which means
so the core difference here between these chains, and if you want to take away one soundbite from today, it's all zk chains are also optimistic. The core difference is how quickly they settle that optimism. So do they get out of that optimism in 15 minutes or 20 minutes, or do they get out of optimism in a week? But ultimately, you're not getting this. You still need to trust someone, an optimistic assumption, for that vision to work.
Steven, following this logic, like every transaction on Ethereum is optimistic. You cannot trust any single transaction. You have to wait 10 minutes or 17 minutes. You cannot pay for coffee with Ethereum because it's not final. It can be still reworked, and there might be a double span.
Absolutely, and there are different levels of trust. The coffee vendor is maybe willing to take the risk of him losing the dollar for the coffee, but you're proposing a vision where there's billions of dollars and hundreds of chains that are fast trusting each other, and you're leaving out the piece that's optimistic.
No,
so you can say it's optimistic because Ethereum's optimistic, that's great, but let's put that piece in the conversation.
That's a little bit of a straw man, because within the ecosystems like zkSync or Polygon, the interactions will our design priority at zkSync is to keep the chain sovereign, so we don't want to build optimistic assumptions in. So we actually, you can wait for the proof to be settled on some intermediate layer. You don't have to wait for Ethereum finality on this, because the reorg will not touch things that happen within the system. If you want interoperability between completely separate ecosystems, then you probably want to wait this time.
with the
That's what we're
assumption
talking
that it has to go through L1 to another.
The conversation here is the interop. Of course, if you're in one chain, you don't have to worry about this because your chain will sort of do its own thing. But the whole conversation here is using zk for interop between two different chains.
Between two different chains within one ecosystem.
I don't know. What is it technically by use?
He's saying interop between like a Polygon zk
between
zk.
How do you technically define an ecosystem, and how are you getting past the fact that what are they sharing that they don't need Ethereum's trust, and they're trusting each other then? Like, where is this trust, right? What does it mean that they're in the same ecosystem? Does that mean that they trust each other? And
I'm gonna just quench my kind of curiosity on this one. I don't remember the full specifics, but I do remember part of the roadmap here is to actually introduce a single slot finality for Ethereum. Am I misremembering this? Like does that change what you just kind of commented on? Do we actually can get to a single slot finality? This will work in the next 2 years or 3 years with those types of things. I'm just kind of curious on that front.
Single slot finality will bring down this interoperability to like the single slot of Ethereum, which is.
But I want to say here is that like the finality is like a security and safety thing also. But finality is also very closely related to the UX and how, if you see all the layer 2's work is that you have a spectrum of finality. For example, if I do a transaction today on Arbitrum, I get an immediate 400 millisecond confirmation. Amazing UX.
250.
250. Amazing UX, probably the best in the industry right now. And the moment I get that, some level of confirmation, I'm already assuming that by the time they will post all the transactions and, state proofs and all that, then there is another level of I know that now the transactions and proof is on Ethereum. And then after 7 days, I can have like full finality, right? And same case, in the zk world also, that's why we have this ag layer, right? Which is aggregation layer which sits in the middle, where let's say if the proof starts coming very, very fast, let's say 5 seconds, 10 seconds proof you are putting on the aggregation layer, an aggregation layer will also have a certain amount of economic security. Let's say a few $1 billion of, let's say, Polygon staked over there, and you get like one next level of safety over there. And then this ag layer is going to post, let's say, every 1-2 minutes to Ethereum, and you get the full finality in 15-20 seconds. So it's all about the user experience, in terms of that spectrum. Also coming back to the OP versus ZK, Polygon is like all, on ZK probably, and people who are active in ZK, you would know, we have probably the strongest ZK team in the space. So much of innovation with Plonky too.
Let you guys fight that out. I'm out of this.
Fight.
No fight. I think a lot of research, we've recently published research with Starkware. I think, zkSync team has Bozoom, which is highly inspired by, Plonky 2 and things like that. So we are contributing open source and anybody can take it. That's not a problem at all. But in terms of optimistic versus ZK world, I think even in the long enough term, there is a space for optimistic, security also, which is crypto-economic security in a way. And how I see the long-term world, or at least mid-term, the world is going to play out is that this whole new internet, trustless internet, it will have large number of ZK, proven chains, but it will also have few large clusters of crypto-economic security. Because the reason for that is that when you have an optimistic rollup, and I'm arguing for the optimistic rollups here, is that the ZK proving there is always some level of cost involved in that. Right now, it's around, compared to the execution, ZK proofs are around at least 1,000 to 2,000x extra cost on top of it.
Are they talking about time or
in terms of even the cost also, okay, right? There is a you can execute the entire Ethereum transactions on a simple $50 machine on AWS. It will take you a few days, or you can compute all the transactions. If you had to prove all of that, that will take you a lot of time. So there is a cost involved there, right? But when you have optimistic rollups, you have a cost of capital, because capital is securing the security, right? There's a slashing and all that, challenge mechanism, all that. So eventually, if the cost of securing the optimistic rollup is, let's say lower than in the cases where cost of securing the rollup with optimistic economic security is less than the cost of proving with the ZK, then in those cases, optimistic security will be better, right? But in case where you have a ZK proving cost is better than, let's say, securing the cost with the cost of capital, it will be ZK forces. So I think the world will exist in at least in the mid run, you will have ZK, rollups and some optimistic.
So to say two things, go for it. No, I love this. This is great. It's actually I'm taking notes. But no, I want to maybe, I don't know where you want to take the conversation, but I just want to
where it's going.
One thing, for the audience, this is kind of maybe amusing, right? And it's great, right? We're not all here kumbaya, but I think this speaks to the strengths, right, of where Ethereum is today, right? Because there's not just one approach, right? There's multiple approaches, there's trade-offs, right? And at Celo right now in the community, the discussions that are going on, right? Are
I'm seeing that firsthand, right? So since the initial proposal, which was with OP Stack, we've actually, core team has taken a deep look at Polygon Stack, at Arbitrum, at zkSync, and it's clear that there's trade-offs to each of the approaches, right? And there's benefits, and there's no like best solution, right? Without like saying this here, right? There's for a given use case, right? For a given even like now one like Celo that's looking to make that transition, right? There's going to be criteria that are going to determine which of these is today the best choice, right? I think the thing to look out for here is where are there situations when you go down this kind of path, right, that creates some lock-in that is harder to kind of unwind long-term, right? Because ultimately, I think a little bit the point that Alex was making, right? Ultimately, we're all building towards this kind of longer-term future of, everything sort of being a lot more open and connected. And I think that's sometimes that gets a little lost, right? And I think, but the TLDR here I would want to take away, right? It's like, hey, there's going to be like billions of people coming into this, Web3 world. You're building applications for them. And the good news is that within sort of the Ethereum world, right, there's plenty of different approaches, and there's even more beyond this panel, right, that are all pushing the boundaries of like giving people a set of features that can map to what they're looking to build. So just maybe as a, perspective.
And first of all, I agree with that vision. And to be clear, I agree with most of what Sandeep said as well, which is there's a lot of value. These guys are building incredible things, and to be honest, they've shattered my expectations. If you look back at my academic history, well before I published the Arbitrum paper in 2018, I published papers on ZK proving systems. So like, even as just a tech nerd, I'm like very, very excited about the work that you guys are doing, and you're doing really fantastic work. And I think, the way we think about things is what's the best technology today and where are we going? I don't know exactly where we're going. I haven't taken a particular bet there, but I believe firmly that today, from a cost perspective, from a maturity and a flexibility perspective, the optimistic rollups are the right solutions, and their ability to upgrade, in time to something that, I don't know. I haven't taken a bet on ZK proving. Maybe the next thing, and I can tell you this, in 5 years from now, there'll be something better. Well, everything we're talking today will look primitive. That's the way it looks if you look back.
Remember when everything used to be about Plasma 4 years
Oh, yes. Plasma and state channel.
Future.
Only one thing I want to just say is there is a common misconception. I don't think this was the main point of what you were saying, but like optimistic rollups don't have what I call crypto economic security, because the staking is basically an anti-spam mechanism. So what happens is the security and assumption in optimistic rollup is that one validator, today that validator set is whitelisted, but once in the vision, anyone can validate, and that's true with Arbitrum Bolt when it comes to mainnet. Any one validator can enforce security of the chain, and if they lose, they have to put down a stake to do that, and they'll lose that stake, and that's sort of an anti-spam mechanism. But anyone can go ahead and do that. So like, it's not the case that the stakes are securing the chain; it's the chain has that assumption.
I actually should have said socio-economic security. I don't know whether you agree with that, because for 7 days, you are expecting somebody from the community to run all the transactions. And if there is a fault, then you run it. So I should have said socio-economic.
Or you do it yourself, right? One of the nice things about Bolt is that you can actually have teaming up people to do it. In the old protocol, it's like someone can like fake, they start doing it and then they sort of lose it on purpose. But in Bolt, you get to sort of commit to your previous. So you have to, you do it yourself or become part of a coalition that's doing.
Zooming out, I just want to say this part also that, everybody should read, there's a Wikipedia page called Protocol Wars, right? So I think all of us are vying for the same vision. This is this trustless, trust-free internet. And these are all
Interoperable internet.
Interoperable. Okay.
Enter.
If there is inter already.
Fair enough.
Right? So the trustless internet. And I think in the medium term, many of these approaches are diverging approaches, but eventually they all come together. And I personally, I'm a big believer on that. I speak to Steven on almost weekly basis.
Not all the time.
And then, everyone OP team, Celo team, everyone. I'm not speaking to Alex yet, but very soon, the time is also arriving there. But I actually want to figure out a place that, where all of the protocols can work together and share value, right? Otherwise, this fight is all value accrual, to be honest.
At the end of the day, you're all fighting for how do we let others win.
Exactly.
And at the end of the day, that's what's the goal that should be maximized. And you have different nuances on standards on what we think this is the best way to approach this. that's fine and acceptable. I mean, the good thing about standards is that there's so many to choose from, right? And we all get there, but
I think it's like kind of shared.
it's a very healthy discussion.
If somehow like, the community, and maybe it doesn't reach, like there is an inherent capitalism involved there and few approaches will win out eventually. But if we could find a way where there could be like shared value accrual across like many of these approaches and they keep evolving into something which is better for the users, that's what we should try.
And we see this on the social layer too. Like if you had a Solana and an Avalanche person up here, we'd all be best friends. So, we have a lot that we agree on, even though we can have...
We're already good friends. We're like, when we fight not with people. We fight for ideas to figure out the truth. And like it can get heated just because we want to figure out like what's the right.
I think this is a great note to end this on. So I want to thank Rene, Alex, Steven, and Sandeep for this amazing conversation. And it looks like we're going to have a version 2 of this thing that's entirely about interoperability. So thanks again. With that, please join us for lunch, and we'll resume in an hour. Thanks, everybody.